So for Chapter 5, it introduces ANT, even though in Chapter 3 we talked a wee bit about the SPI communication that our microcontroller uses to talk to the ANT chip. Okay, so we've already touched on this a bit. But now we want to look at what really is the ANT radio. This is the first part of MPG where we're not looking at something on the microcontroller, we're looking at an external IC that really is its own microcontroller. It's running its own state machine, it's doing its own thing, and we have to talk to it and use it. Okay, so it's much more complicated to interface with some sort of external device, because what you have to do now is go and download all the documentation for that device and figure out the protocol and everything that you need, all the details, to make your processor talk to that processor to make it do what it's supposed to do, and that is, of course, wirelessly transmit. So there's quite a bit of stuff in there, and therefore quite a bit of work. First time I ever worked with ANT, it probably took me 2 or 3 weeks of full-time work, so 120 hours, banging away on this thing. The most challenging thing that I've come across in engineering is when if you don't have someone as a mentor to help you with something, and you're learning something brand new, it's very, very challenging. Even the simplest things, like a single bit that might be wrong, that you don't quite understand, can make nothing work, and therefore if nothing works, how do you even take a step forward, and where do you look to troubleshoot, right? So it is definitely hard. Just like with MPG, you've seen that with a known working hardware platform, then it's easier to get firmware up and running. If you have unknown hardware and unknown firmware and something doesn't work, well, where do you look? So one of the important things with ANT when I was learning it was to buy their development kit for about $650, and that was a known working hardware solution, and then you can start banging away on firmware and address that, so you can actually see, you know, the device is supposed to respond, you know the device is supposed to broadcast, so as long as it works, which it does, then it's your fault when stuff doesn't work, and you just work through and make that work. Okay, so there's definitely a lot of effort there, but once you get it, and once you have an understanding, then you start, it's a breeze. And usually, I find that I tend to make things more complicated, like I'll read something in the documentation that says do it this way, so I'll try to do it that way, but I might add my own twist to it, and then it doesn't work. And then in the end, you've done exactly what they told you to do in the first place, and it works, surprisingly. So you have to really trust that documentation, but sometimes, that being said, documentation is wrong. They'll tell you something and you'll do it 1,000 times, and finally you'll be on the phone to someone and they'll say, oh, by the way, there's an update to that document because that was wrong. So don't totally discount yourself, but generally speaking, when you're working with someone else's system that is released into the world and being sold to everyone out there, if something doesn't work, it's your fault. Okay, so you have to figure out what that is, and their tech support will help you do that. So, with ANT, ANT is a protocol. They being Dynastream out in Cochrane, the ones that like this course, and because I put the ANT radio on this board long before they ever knew MPG existed, so they're very supportive of MPG. They give us the ANT radio chips for free on the boards, and they're about a $5 chip, so that's nice to have there. So Dynastream created the ANT protocol, and the ANT protocol is sent back and forth between 2 radios or multiple radios at 2.4 gigahertz. So there's, if you look at all the wireless spectrum out there, 2.4 to 2.5-ish gigahertz is an industrial and scientific band. So you are allowed to some degree to transmit in that band without a radio license. Okay? It's not like a cell phone band where you're not allowed to be there. If you are caught broadcasting at 800 megahertz, which is where your iPhone works, then you can get a serious fine from FCC or whatever the Canadian equivalent is of that. Okay? So 900 megahertz, 2.4 gig, 5.8 gig, those are all ISM bands. 2.4 is a very good one to use because it's worldwide. Okay? The 900 band is only North America, and Europe doesn't have that band, but 2.4 gig is available worldwide, so you can take this device and go over to Paris and use it without getting in trouble. Okay? So let's write that down. So 2.4 gigahertz. up to, I think it's, let's say 2.5, close enough. Okay. So somewhere in there, you can choose a frequency to transmit at. Okay. If you, what else is in that band? Do you guys know? In this room as we
Wi-Fi.
speak. Wi-Fi. Okay. Wi-Fi is in that band. What else? Very common.
Cordless phone.
Cordless phones are in there, and another really common one. You might have an earpiece.
Bluetooth.
Bluetooth. Okay. So it's a heavily used band. There is ways to share frequency space, but if you have too much power at particular frequencies, then one signal will drown out another signal and it won't connect. Okay? You'll either have total loss of data or partial loss of data. So with ANT, by default, it doesn't do frequency hopping. So Wi-Fi, Bluetooth, they both bounce around all through the band. They have a scheme that says I'm going to transmit here for a couple milliseconds, then I'm going to go here, then I'm going to go here, then I'm going to go here, and that helps if you get stuck at a particular frequency, and you get a bunch of errors. You don't have to worry about it because in a few seconds or a few milliseconds, I think it's maybe 100 milliseconds, don't know, you'll go to a different frequency. And I'm not sure if it learns with frequency hopping, but whatever, it'll go there and move around. Generally speaking, there's not going to be a single frequency that's like a high power transmitter stuck at a particular frequency. So even if at one time through your hopping scheme you hit a bad part of the frequency because something happens to be also hopping there, the next time you come through it, then it's probably okay. And by default, like I said, only you pick a specific channel. So we're going to be broadcasting at 2.45 gigahertz. So actually choose that channel and we'll not deviate from that. They have introduced frequency hopping, but for most applications, people aren't using that right now, so single frequency. The transmit power of this radio is 1 milliwatt, okay, so 1,000 times less than your cell phone. Okay. You are not going to talk to a device kilometers away with an ANT radio. Okay. The best you can probably do is about 100 feet, and that's line of sight in perfect conditions. The whole ANT system is meant for something that we call a personal area network, or a PAN. So really, the purpose of ANT is about this much space around you. Okay? That's what it's trying to connect to. Okay? It really isn't trying to talk to Kyle back there, but you can. Okay? So what I found with my experiments with ANTs, 100 feet line of sight is probably possible, but a little sketchy. 30 feet, like within this room, no problem. Okay? You might get an odd error now and then, but generally speaking, it will work with that. Okay? If you really want reliable 100% communication, then you need to, like I said, stick in this sort of range. The data rate on ANT is a maximum of 20 kilobyte per second, which is not very fast. It's not like Bluetooth, okay? But there's reasons for that. It doesn't have to be because of the applications that it's intended for, so they don't try to do that. And by not trying to do megabits per second, then they have a lot of other advantages in power consumption and even just in the simplicity of the protocol that they use. So it's definitely a niche. Bluetooth Classic has been around for quite some time, and I think finally this year Bluetooth Low Energy is out now, so you'll see BLE on some cell phones now. BLE does not speak to Bluetooth Classic. They're separate, even though I think they're encompassed all in the Bluetooth spec now, but they're not interoperable. Bluetooth Low Energy is more of a competitor to ANT and another technology called Zigbee. So you might have heard of Zigbee, you might have heard of Bluetooth LE. There's all these things out there. Okay? As far as power consumption, and I'm going to say ease of use, ANT is number one. You can run them ridiculously low power. You can run on a coin cell battery for years with them if your system is designed correctly. Data rate is slow. As you'll see, it might look a bit complicated at the beginning with their protocol, but it's not that bad. You can do an ANT stack probably in less than a kilobyte, maybe 2 kilobytes. So your complete protocol can be encoded in firmware in less than 2K. Okay? Bluetooth, 100 kilobytes minimum for a Bluetooth stack. And BLE, I'm not sure what it is, but definitely more complicated. Same as Zigbee, you're looking at, I believe, around 100 kilobytes to do a firmware implementation of that. So that would consume more space on our processor than IR supports right now with the Kickstart version that you guys have for free. But with Ant, we can build Pong, we can put Ant, the whole protocol on there, or at least a partial subset of the protocol, and do everything else, and we still got tons of space on the processor. So it's nice and tight that way. If you look at a system as it's set up, so this is kind of our dev board. We have our MCU, which is considered the host in the system. And then you've got Ant, okay, and then it's got an antenna. Okay. This communication here is SPI plus a little bit of handshaking. If you're talking to another Ant radio on another dev board, it's the same thing. You've got the Ant chip, you've got your host, they talk, and they receive back and forth over the air. Now, there are, in the radio relationship, you're always going to have a master device and at least one slave device. That's how it works. It's a master-slave relationship. You can talk to multiple slaves, but you can only talk to one master, generally speaking. So that covers the over-the-air interface. So host, Ant, OTAs over the air, master-slave. The other communication that you have to worry about is your host just to Ant. So sometimes you'll be talking here exclusively. Sometimes you'll be saying, well, I want to actually go over the air, so you'll send a message that tells Ant, I want to go over here. There are, because you can have a ton of different devices all floating around, sharing the same space, there has to be a way to share that frequency and to sync up with a particular device that you're working with. When these guys talk back and forth, there are three ways or three message types that they will use to communicate. Those message types, and you do need to know this. So there's something called a broadcast message. There's something called an acknowledged message. And there's something called a burst message. So three different message types. We won't worry about that. If you want to get that 20 kilobytes per second, you have to look at bursting. I've never actually done it. It's on my list of things to do. But every application that I've worked with Ant, it's only small bits of data that we're exchanging. Even for Pong, we only use small messages back and forth. We don't send a lot of data, even for Pong. These two guys here, consider this as the fire and forget message. Okay? If this guy or this guy, both of these can send broadcast messages. If this guy sends a broadcast message, it goes over the air, and this never knows if it got received by the intended recipient. Okay, so broadcast literally just says blah, blah, and continually sends that out. Okay, and that's okay. There's lots of times where that is a perfectly acceptable message type to use. Okay, when you don't care if the data is received. The other message is an acknowledged message. So with this type of message, the structure looks essentially the same. So the same amount of data goes out in one little packet, and it requests a response. So as this broadcasts, it'll send out a message, and on the next message period, it'll get a response if that receiver device has actually listened or received that message. So it gets an ACK. So that's for data that's critical data. Okay, so you need to know if data gets into a particular space. There are some very interesting problems when it comes to situations where two systems are trying to decide if the other has received its info. Okay? Because this link is very prone to losing bytes. So even if this guy, and we run into this, you'll see later, this guy could send an acknowledged message with critical information, and this guy would give an ACK back for that critical data. but he doesn't know if his ACK was received. Right? So you run into a condition where you could endlessly say, here's a message, did you get it? Yeah, I got it. Did you get my response? Yeah, I got it. Did you get my response to your response? Yeah, I got it. Did you get my response to your response to your response? And you never actually know. So you have to be able to handle that. And you'll see with our Pong data going back and forth, there are times when particularly the hardest part was starting the game at the same time on two devices. Okay? And this synchronization problem was the kind of the root cause of a lot of pain and agony to try and figure that out. And there's actually, the way I did it, there's better ways. Anyways. So these guys talk back and forth. You could have two identical devices. Of course, we've all got our development board, so we're all going to be talking at the same time. So what we need with all of these messages, regardless of one of the three types they are, we have to have a way to distinguish our particular message. And that comes in with the channel ID. So the channel ID is very important when you're configuring your device. So before you ever open the channel here, when you turn on the power, your device is not broadcasting anywhere. It's just sitting there waiting to be configured and then waiting to be told to broadcast. So the first thing that you'll do, and we're going to look at this today, is configure this guy to tell it of, among other things, what its channel ID is. So the channel ID has something that we call a transmission type. And it's 1 byte. And there is, let's not get it wrong, the device type. It's 1 byte. And then there's a device ID. And it's 2 bytes. So you've got 4 bytes to completely distinguish your device from other devices. If you have a bunch of common devices, if you want to play Pong, it's very likely that these two parameters would be the same. So like devices have like transmission types and device types. Okay? So you sort of put it on a class of its own to segment those things. So maybe if you're doing an audio driver, it would be a device type 1. If you're doing a Pong game, it's device type 2. If you're doing some other sensor or something like that, maybe it's device type 3. So right off the bat, you can get some orthogonality between your devices just based on the type, or similarly with the transmission type. Okay? So even if you had a Pong device with the same ID as a sensor device, because they have one of these that are different, they won't collide, even if they're talking at the exact same time. Ant here figures that out for you. This is a wee bit of a problem that they only chose 2 bytes, and I believe they regret that. However, because that only gives you 65,000 or so different devices that can be entirely unique. Right? So if you're selling commercial devices, and Ant is very big in fitness and in cycling, so the cycling world, if you're a cyclist, you probably have an Ant Plus device with you. Now the problem is, with only 65,000 devices and millions of users, you get a lot of repeated device IDs. So you have to work your way around that, and it's not set up by default in the protocol. So there are ways to get around that. The key fob that I built for Blackline that uses Ant, we use this, plus we have an additional 4 bytes that we use to distinguish our devices. So we have 4 billion possible different devices. So then you've got a reasonable chance that you're not going to get duplications. Okay? So, but you have to manage that. So you have to understand the technology that you're working with and mitigate anything that comes up. I kind of missed this point of Ant versus Ant Plus. Ant Plus is a defined set of profiles, just like Bluetooth uses profiles. So Bluetooth has an audio profile, for example. If you build a Bluetooth audio device, then you adhere to particular rules. You have transmit parameters that are are set based on a standard. You have communication protocols that are established. ANT Plus works the same way. So there's an ANT Plus blood glucose monitor, there's a heart rate monitor, there's a pedal power monitor. I think there's something like 20 different or maybe 30 different device profiles in ANT Plus. If you build an ANT Plus device, because you've built it to a standard, you're guaranteed to be compatible with everyone else's ANT Plus device. So if you wanted to build ANT Plus on your development board to listen to all other ANT Plus heart rate monitors, you could code that as a receiver for ANT Plus heart rate monitors, and of the hundreds, literally hundreds of heart rate monitors that are out there, you could turn them on and they would pop up on your device. Okay, that's the beauty of the standard. Problem with standards is that you have no freedom. Okay? If you don't comply with what the standard says, then your devices aren't going to talk. A lot of people only want ANT Plus devices. If you need some level of customization, you can use ANT without, they call it like a proprietary mode. You are supposed to buy your own ANT network ID. It costs about $5,000 to buy a network ID. And that is assigned specifically to a company. It's an 8-byte number that is unique for a company. So that network ID is an overshadowing parameter of all of this stuff. Okay, so if you have a unique network ID, then you could have all of these matching exactly to some ANT Plus device, but you wouldn't collide because your network ID supersedes all of that and makes your data stand out. Fortunately for us, even though we aren't using ANT Plus, there's a public network ID for development. Okay? So it is 0000 8 times. So that's what all of our network IDs will be set to. Okay? And there's no guarantee that you're not going to collide to something else, because there's no rules about the public ID. Okay? So we'll have collisions in this room when we have the same data types, but we won't collide with any other devices unless there's fourth-year projects that are using ANT also on the public channel with the same parameters. Okay? But it is fairly difficult to start colliding. So that's kind of neat, and that's particularly neat because you're all sharing that same frequency. And I haven't seen this for myself, but I've been to the ANT symposiums where they have literally hundreds of different people with exactly the same devices all talking. One of these device IDs might be different, and it works flawlessly. Okay? So it's almost impossible that it works flawlessly, but somehow they have done that with the protocol. So it's pretty strong. If you have two devices, generally to get them to start talking, you go through something called pairing. So pairing is a function of the ANT radio syncing up with each other. So the process works that your host device configures ANT with the network number and all of these parameters. Okay? You know what you want to talk to. Okay? So you're going to set your transmission type, device type, both the same, and then you're going to specify a device ID that you're looking for. Right now, by default, all of our device IDs are hard-coded. So you probably want, later on, you'll want to have a unique device ID for your device. And if you're in boring lectures and you want to be playing Pong with someone else, then make sure you guys have the same device ID so that you can hook up wherever you are in the lecture room there. Okay. But for now, everyone is the same. Okay, so you could have collisions. Once that channel configuration is complete, so you specify all this, you specify your frequency, you also specify the messaging rate, then you can, the master will open its channel and it'll start sending broadcast messages. At the same time, your slave needs to have its channel open and it'll start listening for broadcast messages. So in a master-slave relationship, the master always initiates the first transmissions. With ANT in this configuration, it takes 2 to 3 seconds for the devices to synchronize themselves and start transmitting data. So as long as parameters are the same, slave channel is open, it's receiving, master channel is open and is starting to transmit, By default, every 4 times per second, you'll get a broadcast message sending out here that provides the synchronization signal for the receiver to figure out that something is trying to talk to it. The details of how these actually kind of lock on to each other and know that they are paired and working are not shared. Okay, so you have the understanding that master opens, slave listening. Inside the protocol, you'll get a message that confirms that you have sent a message, and then you know that you're synced up. Okay? And that's all handled by the protocol. The slave will tell you if it loses, so it'll say a channel has been established, and the master will continue to send messages, kind of like a keep alive type signal. And as long as the slave keeps hearing them, then it'll say, yes, I am connected to a device. By default, you're always going to be sending broadcast messages. This is probably the strangest part of ANT. So what you have when you've got an open channel communicating, there's a little buffer in here in the ANT chip that has the data that you want to send. So it's 8 bytes. That's your maximum data payload for a data message that you're sending to the other device. If you say, I want to send 1, 2, 3, 4, 5, 6, 7, 8, you give that to ANT, and it keeps it in a buffer. So the next time a message goes out, it'll send 1, 2, 3, 4, 5, 6, 7, 8 over there. If you don't tell it to update that message before the next message period that's automatic, then it will send that same data again. So if you only update your message once, then it'll keep sending 1, 2, 3, 4, 5, 6, 7, 8 every tick of the message period, so 4 times a second. And that is a necessary signal to keep those 2 channels linked. Because you know that's how ANT works, you handle that. Okay? So one thing you can do is, in what we'll do for ANT, to avoid redundant data, whenever we send a message, we stick a message counter on it. Okay? So every time I send a message, it might have the same data, like I'm waiting for your user to press a button. So it continually sends that message. And until it gets something back, it won't change that. But for us to know, and for the system to know, for example, maybe how long it's been waiting for, every time we'll use 6 bytes to say I'm waiting, but then we'll also stick 2 bytes of message counter on there. So this one knows how much time has elapsed. Okay? And this guy knows how much time has elapsed. Okay? So you start to use that. And as long as you keep updating your broadcast message, then you're always going to be updating your message number. But if you stop, if you just open the channel, then whatever's in this buffer will always be sent, and the slave will always receive that. They'll say, hey, I just got this message. So it can do that over and over again. So you have to handle that. There are 2, I guess, states. I like to classify them as states for an ANT system, and that is channel closed and channel open. Because once the channel is open, there's a whole bunch of stuff that goes on with the messaging, versus when you power up and it's closed, it's sort of calm. Nothing happens unless you initiate something. So that's the host configuring ANT. It can request version numbers, it can set channel IDs, all that. These guys will talk, but nothing is coming in. As soon as you open a channel, then you're at the mercy of unsolicited messages, meaning this guy can get a message either from ANT because an event has occurred, or from data when this might not be expecting it. And so it becomes a bit more complicated because this guy has to make sure that any messages that this guy initiates, it will handle. Okay, so your system always has to be ready to receive data that comes in at the same time that it's transmitting data and managing all that. So radio systems are a bit complicated. Same if you're doing a GSM module. So at work with our tracking devices, same kind of thing. We can talk to the module, in this case it would be a GSM module. For a lot of messages, we're either sending data out or configuring the module, but a lot of times someone banging away on their web page says, well, I want a device location. So this guy can be sitting, happily sleeping away, and all of a sudden over the air comes a request for a location. So it has to pick up that request and send it. So just like this system, especially in your slave, it can be sitting there listening, and all of a sudden messages start coming in. As soon as the channel is open, not only are there data messages, but stuff happens. So this will give you status messages back to your host about the channel and the condition of the channel. Have you lost messages? Is the channel active? Has a broadcast message been sent? Have you received an ACK from an acknowledged message? So the state machine that we are going to be developing for Ant handles all of that for us. Today, we are going to look at just getting the configuration of Ant working. Now, all of the SPI communication stuff is done already. Okay, that's chapter 3. All that's taken care of. This chapter focuses on going and finding documentation for Ant, and I would like you to do that. There's, in the links directory, there is a link to the Ant documentation, so you should go at least look at that and see where it is. Okay? Their documentation isn't that long. Okay? The notes as you go through them will tell you what to look for and why you need to look for that stuff. And then it'll go through and kind of give you, kind of highlight the points about what you need to know to get Ant working. For today, and the lab exercise today, you can go directly to the very 29th page or whatever it is where the chapter exercise begins and just work there. Okay, so it's you aren't writing any code in this chapter, you're learning how to use Ant. Okay, so it'll take you through, there's a bunch of marks in the code. I think it's pound MPGL2. So remember, Control-Shift-F is find in files. So if you do that, there's 6 or 7 different locations. Go to those locations and you'll see notes in the code that describe what you need to do. Okay, so a lot of it is setting up your environment. What I want you guys to do is get your transmit buffers and your receive buffers in watch windows. Okay, so you can see messages get queued and responses back from Ant, and start to see what those responses are. Every time these guys exchange messages, there is a strict format that the message comes in at. So let's write that down as the last thing before we get started with this. I'm going to do this from memory. So the first thing in any data, any frame of data that's sent for Ant, there's a sync byte, and I think it's OXA5. Then there is a length byte. So that there are variable length messages with Ant, which is kind of nice. So if you only need 1 byte of data or to do a command, then you don't have to waste extra bytes sending nothing. For data messages, you always send 8 bytes of data. So this length can be anywhere from 1 to, I think the maximum is 15 or so. And then there's a message ID. And that is just part of the protocol. So in one of those documents is all the different message IDs that you can use. So when a message ID comes in, your state machine has to look at that ID and say, what is this message telling me to do? So it has to code all of those message IDs. Our system will only code some of those. It's only going to code the ones that we expect. Okay, so that's a nice thing about Ant, is that you can implement a subset of the protocol as long as you aren't doing Ant Plus, because it has to respond to everything. But with our proprietary system, we can just do what we need, so we can keep our code size down. So message ID, and then there's, I think, a channel number, your payload, and then checksum. So it's just a XOR checksum at the end. So you should see, every time your receive buffer gets a new message, you should see this structure. You'll see the better description of this structure in the notes and in the documentation for Ant. So learn to recognize this, because you will need to be able to look at these messages when we're coding Pong. If you want to have any hope of understanding the protocol for Pong, you need to understand these messages, and you need to use the tools to be able to look at the messages, because you have to see what's coming back from other devices or what you're getting. So get that. I'm going to show you one little thing. The rest of the, like I said, there's in all of these hash marks. There's instructions on what to do, what to look for. And what I'm going to have up here is the test hardware and test firmware, or not firmware, but test system. So I've got a little USB dongle on here. So this is from my $650 dev kit. So I have stolen it from work. And by stolen, I mean borrowed. This software that looks like this is called Antware. So this is provided by Dynastream. So in this particular software package, this is the USB stick parameters. So you can get different parameters or different capabilities on different USB sticks. So you plug them in here. All of this stuff is how you configure this software and that dongle to the channel IDs and the network IDs that will work with. And then you can fully test with a known working solution. And this window here that I'm moving around is going to report data. The firmware that's running on your boards for this is just the board test firmware. So you know if you press the button 1 or whatever it is, then your ANT radio, I told you, is broadcasting, even though all you heard was a buzzer, right? But now, when you broadcast, oh, come on. It probably shut down my USB stick. Just a second. Sorry, when the computer slept, it reset my thing. I'll get this working in a sec. This window here is a copy of that. As soon as your radio is transmitting, you'll see this start scrolling messages. So I'm going to leave this sitting here on the board. So at your workstations, you can hit your buzzer and you'll see these messages start to move. Okay, so that you can verify that actually things are going on there. And if you want, you can come up here and send yourself messages back, and you'll be able to see those come in to your system. But for now, even just as a quick test, you can verify that your radio is in fact working, which is probably something you want to do. So let me just restart this, and then we'll have that capability. So I'll have it up here running. I can't believe that didn't work. It's so sad. Let's just try. Oh yeah, so it's definitely, I just need to reset the USB stick. So I'll have that working. And I think if you guys are all in this row of computers, then you should be able to see that as it comes up. If everyone's broadcasting on the same channel, we will get some collisions here, but not a big deal. You'll just see what happens when you get collisions. If you want to change your device ID, you can do that. This particular USB stick has something called a scanning channel. So we can, our device type is 96 and our transmit type is 1. Okay, that's hard-coded in your firmware. You also have a hard-coded device number. If you find that, you're welcome to change it. This guy is listening with the same device type and transmit type, but a wildcard device number. So this will hear every device ID as long as the transmission type and the device type is the same. So you're welcome to change that, and then you'll be able to see some of the message data that comes through includes the device ID from where it listened to. So you'll be able to see your device on there. So get that up and going. We've got half an hour to do that, and hopefully you'll be able to see your radio transmitting and start to pick through the little tasks that are all in the notes or in the code for you. All right?